Hello everybody, I'm Nick. In this video I'm going to show you how you can measure how long something took in your C# codebase correctly, and I can guarantee most of you do this wrong. In fact, if you're using the datetime struct to do that, you are doing it wrong. And even if you're using the right class to do it, depending on how you do it, you might still be doing it wrong. So let's take a look at what we have here. So I have an API and I'm going to add a measurement for the request that this API has. It is a weather API, it doesn't really have anything. And the first thing I'm going to do is I'm going to add an artificial delay to sort of imitate that something takes some time to execute. So I'm going to say task delay random.shared, and I'm going to say next, and we're just going to give it like an upper and a lower bound just completely randomly. And then what I'm going to do is I'm going to add a middleware. So I'm going to say app.use, and I'm going to use the context and then the next function. Here we go. And basically, to understand how this works, it is as follows. I'm going to await, because I'm going to turn this into an async method too. I'm going to await the next by passing down the context. And if I do that, look what I can do. I can grab a logger. So I can say logger.context.requestedServices.get requested service, and I'm going to get the ilogger of the program. Here we go. And I'm going to say logger, and I'm going to say logger.log information started, and then after the awaiting of next, I'm going to say ended. So if I do that and I quickly run my API, let's see what will be in the console. So API is running. I'm going to go over here in Insomnia and call the weather endpoint. And as you're going to see, I'm going to get my weather after a short delay. And then I'm going to get started and ended. In the meantime, there was also the request. In fact, if I go to the app settings.json and I decrease the warning of ASP.NET Core level to information, and I call this API again, this just reloads the settings behind the scenes automatically, then watch what happens. I have my started, then the request is called, the executing, and then executed, and after that, we get the ended, and eventually we get some diagnostics on how long things took. So this type of thing allows us to add an inline sort of middleware for APIs in .NET. So now that we have a way to measure it, let's see how we can measure it. I'm very certain that many of you do the following. You get a before datetime.utcnow and you store that. And then later you say var delta and you say datetime.utcnow minus the before. And what that gives you is the difference as a time span between the two date times, because the subtraction operator is actually overloaded in datetime, and it turns the difference into a time span by subtracting ticks. So we can do that. And then since we have the delta, we can say ended after, and then let's say time. And I'm going to pass down just the time span and let it show us what it is. So I'm going to run the API. I'm going to go back to Insomnia, call this endpoint. And what you get in the end is ended after 574 milliseconds. So we have a way to do this. However, this is wrong. This is not the most accurate way or the most performant way to do this sort of thing. The reason for that is because in datetime.utcnow, you have a lot of code, which takes into account a lot of date-related things like leap second cache, which is being built with this operation, bunch of other things. We go here, we have a lot of unsafe stuff to try to make sure it's as performant as possible. But there's a lot of code, and even though datetime is a struct and it won't allocate on the heap traditionally, like if it was a class, it is still not a great way to do this. You're going to lose some of that delta because creating the UTC now takes time. So if you want to be very, very accurate, this is out of the picture. If you're using this, remove it. So what should you do? Well, I hear many of you saying in your head, Nick, just use the stopwatch. And this is partially true. But if you're doing the following, if you say var stopwatch equals new stopwatch, and then you say stopwatch start, and then after the operation, you say stopwatch stop, and you just print over here the stopwatch.elapsed, which is a time span again, and you do the following, if you just restart the API, then yeah, we're going to get that delta, and it is 590 milliseconds now. This again, it's random, so it's drifting, so it doesn't really matter. But even if you're doing this, there's a bit of a performance issue, because now for every single request, you're allocating an extra stopwatch, which we don't want to do because the stopwatch is a class and the class will be allocated on the heap. So for every request, you're going to allocate an extra thing, which, in a grand scheme of things, it is not a big deal, but it is still not ideal. If you can save some allocations, you should. And in this scenario, we can actually save them and completely remove them. Now, if you're using something like this, where you say var stopwatch equals stopwatch.start new, and you do something like this is still wrong. In the same way that new stopwatch and then stopwatch.start is wrong. Yeah, this will measure everything, and we are going to get over here how long it took. However, start new is nothing special. Behind the scenes, it's just a wrapper that creates a new stopwatch, starts it, and returns it. So it's like a shorthand of doing new stopwatch.start. So what should you use? Well, in .NET 7, we got some really cool methods in the stopwatch, but in my opinion, it didn't have to be in the stopwatch. It could be in the datetime class. It could be anywhere. I think it kind of makes sense to be in the stopwatch. But what did we get? Well, we can say start time equals stopwatch.get timestamp. And this returns a long. This is not a datetime. So, okay, it is a struct, good, but it's in the stopwatch class. So is it creating a new stopwatch? Well, the answer is no. It actually is really smart. It is going deep into the OS and the architecture that you're running on, and it is getting a very specific, you guess that what it's doing when I'm hovering over is it's using the kernel 32.dll lib, and by the way, this is specific to any architecture. So this is Windows, it knows it's Windows. So that's why I'm seeing a kernel 32. This doesn't exist on Linux, you're using the equivalent, and same for Mac and so on. And this then is setting that long timestamp from that interrupt and then returning the timestamp. Of course, all of this is marked as unsafe, but because it is unsafe by Microsoft, it is safe and it's just made for performance. That's why they did this. So ultimately, you have a starting point now, and well, what do? You say datetime in the end, and then you have a stop time. But remember, this is actually a long. It is not a timestamp. So what is the long? Well, the long is actually ticks. And what are ticks? Well, ticks are just a further more accurate way to measure time. And there's 10,000 ticks in 1 millisecond. So you can go really granular. And then we have the start and the stop time. And I can say stop time minus start time. And if I do that, then what I'm getting in the end is, well, let's go ahead and call the endpoint and see what I'm getting. I'm getting ticks, which in this case is 642 milliseconds. Now, this is fine on a functional level, but could this be better? The answer is yes. What we can say actually is var delta, or elapsed time, and we can say stopwatch dot get elapsed time. And you have two overloads here. One to just pass the starting time. And if you just pass the starting time, it's going to assume you're stopping now. So it's going to give you elapsed from when it started all the way to now. But you can also say the start time is this, and then you pass down an end time, and it's going to give you the delta for this operation too. Or we're just going to use the single start time here. And what we get in the end here is actually a time span. So it's going to do the conversion from ticks to time span and the subtraction for us. And all we have to do here is we pass down the delta, we restart this API, we are calling the endpoint, and now I can see exactly how long it took in a time span. And this is the most efficient way to do this. In fact, Microsoft is using this all over the place. They replaced all the other types of measurements with stopwatch. In fact, Microsoft wasn't even using the stopwatch class behind the scenes. They had made their own version of the stopwatch called value stopwatch. And that was a struct, meaning it could be allocated on the stack instead of the heap if the conditions allowed. But here you don't even have to worry about structs and classes. All you have is the long and a time span, and then you just calculate the delta and you return it. So if you're measuring time, please use this. Don't use new stopwatch, don't use start new, don't use any of that. This is the best way we currently have natively in .NET to measure a delta of time between 2 points. But now on from you. What do you think about this, and what have you been using until now? Are there any libraries that you've used to do this? Leave a comment down below, let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.